Hello, welcome back everyone. Welcome back to this channel, The Math Mentor. Through this video, I will try to make you understand. I'll try to make you understand rational number, right? Rational number and its decimal expansion. Decimal expansion. Right, so what we have in its decimal expansion, what's so special about its decimal expansion? So in this case, what we have, there are three different cases that you need to understand. Suppose p by q is my irrational number where my q is non-zero, right? So I have three cases. These three cases I'll be explaining to make you understand what I'm trying to tell you through this video. So these three cases is what I'm writing the form of Q. I repeat, I'm writing the form of Q. So if this Q is of the form 2 raised to m, where m is positive integer, right? Where m is positive integer belongs to I. Or if this q is the form of 5 raised to n, where again n is positive integer and n belongs to integer, or if this q is of the form 2 raised to something, n into 5 raised to n, right? What happens in these three cases? Let's understand, right? Let's take a very small number. Just to make you understand. Then slowly I'll increase it. I'll take two examples of everything. I'm only talking about 3 by 4, where I'm just taking the example of first one. So where this 3 by 4 can be expressed as 3 by 2 square. When this is 2 square, this can be changed as I can multiply the numerator and denominator with 5 raised to 2. So what will happen when you're multiplying? This will become 25 3s are 75. Your denominator will become 10 raised to 2, which means 0.75. Another case I'm taking now. For this one I'm taking 3 upon 25, or you can take 125 as well. That's your wish completely. So this will become 3 upon 5 square, which can be converted in the form of 3 into 2 square upon 5 raised to 2 into 2 raised to 2, can be written as, this is 4 3s are 12, this is 10 square, which is nothing but 0.12. Let's see one different case, right? Directly third case. Let's take 3 upon, I'm taking it as, let's take 20. So when I'm taking this as 20, this is nothing but 3 upon 2 raised to 2 into 5. 2 raised to 2 means 4, 5s are 20. Can be expressed as 3 into 5 upon 2 raised to 2 into, already I have multiplied 1 5 in the numerator. I can multiply 1 5 in the denominator. So this will become 5 raised to 2. So I'll be getting 15 upon 10 square, which means 0.15. So what here I wanted to tell you all, whenever your denominator, I repeat and I emphasize on this, whenever your denominator of the rational number, whenever your q is of the form either 2 raised to m or 5 raised to n or 2 raised to m into 5 raised to n, your decimal expansion will be always terminating decimal expansion. I repeat, your decimal expansion will be always a terminating decimal expansion. What happens if your denominator is not of the form 2 raised to m or 5 raised to n or 2 raised to m into 5 raised to n? Let's see further examples. Example 4, I'm writing this as, let me take 2 by 3. We all know now this I cannot make it of this any of this form. I have other number, so this 2 upon 3 can be written as 0.6666 and so on. Another example I'm taking, right? So let's take 2 by 7 or 3 by 7. So when I'm dividing it by 7, this will become 0.72 are 14, 6 is there, 7 8s are 56, 4 is there, 7 5s are 35, 7 7s are 49, 7 1s are 7, 7 4s are 28, right? After 28, remainder is 2. So when the remainder is 2, that means again it will become 20. That means my decimal expansion is what? Recurring one, right? I hope it is clear. When I'm dividing 2 by 7, so I'm taking 20 and I put one decimal. 7 2s are 14, 6 is remaining, it will become 60, 7 8s are 56, 4 is remaining, it will become 40, 7 5s are 35, 5 is remaining, and then 7 7s are 49, 1 is remaining, it will become 10, 7 1s are 7, so it will become 3 is remaining, 30, 7 4s are 28, again 2, right? That means what I'm trying to tell, if we have denominator other than these things, other than these forms, right, after the prime factorization, then your this decimal expansion will be recurring decimal expansion, recurring and non-terminating, you can say non-terminating decimal expansion. So this is very important to understand rational numbers and its decimal expansions. Any rational number is of the form p by q if your q is of the form 2 raised to m, 5 raised to n, or 2 raised to m into 5 raised to n, where this mn are positive integers, belongs to I, right? These are the some examples which demonstrates that when you have these forms as a denominator, the decimal expansion is terminating decimal expansion. And when you have any other number other than this, for example 2 by 3 and 2 by 7, they are examples of recurring and non-terminating decimal expansions. I hope you have understood this. Hope you like this video and you will share it with your friends. Thank you for watching this. Thank you.